Welcome to using F-rotators in Unreal, a new type for you. By the end of the video, we will understand F-rotators better, and we'll actually have a desired roll, pitch, and yaw for the barrel coming out of here, rather than just some arbitrary world space coordinates. So let's see how that's done. So we've got our unit vectors being printed out. We know what direction we want the barrel to head to. We better start getting some code that can actually move the barrel now. So firstly, let's just go back to our AMAP method, do a little bit of a tidy up. So thank you to Daniel who pointed out that the parameters after launch speed, if you look here, high arc is false, collision radius is 0, override gravity is 0 are the defaults. So for those three, we actually don't need to put those parameters in. So I'm going to remove those three parameters from the tank aiming components aim_at method. Just to make the code shorter, less lines is always good. The other thing we can do to make the code a little bit more readable, make it a bit more explicit what's going on here, is we can just move this into a bool. We can say bool b have aim solution, because that's what we're talking about, that's what we're actually doing. And all of this code here is about getting an aim solution, like so. So b aim solution is that. Then we can bring all of this in by one level of indentation, which makes life simpler again. And then that is the definition of our Boolean. And then we can just say if b have aim solution, oops, if I could type straight, like so, then we go ahead and do this stuff. So apart from the fact I've got an extra closing bracket, hopefully that makes more sense to you. So if we don't have a barrel, we get out, we have an out parameter, we have a start location, so the start location is used there, the out parameter is used there. Then the whole result of that thing is, do we have a solution to the aim? If yes, then let's carry on. So how do we carry on? Well, what we're going to want to do here, rather than just logging out, is we're going to want to move barrel. Ultimately, that's going to both elevate the barrel and rotate the turret, but for now, it's just going to move the barrel. So I'm going to suggest that you pseudocode what this move barrel method is going to do as your challenge. I want you to abstract at a higher level than the actual code. That means that when you pseudocode, don't put one line of comment for every line of code. You want to think a little bit higher than that. A line of comment could lead to several lines of code. Use plain English and have fun. It's just an exercise. There's no right or wrong. I want you to think through what the algorithm of moving the barrel may be, just so that you've thought ahead before I show you how I do it. So go ahead, pause the video and pseudocode move barrel right now. So welcome back, guys. Right, well, what I'm going to do is actually write the move barrel signature firstly, and then I can pseudocode inside the actual method. So we're going to have something that's void. It's going to be move barrel. It's part of the tank aiming component class, so let's prefix that there. And then we also need to declare that, of course, in the header file, bit of C++ noise. So let's go ahead and do that right now. Now, it may be that this takes a parameter, but for now, let's think about it without the parameter, and then we can always add a parameter in if we need to. So void move barrel like that. It's private. A method from the outside of the tank aiming component doesn't need authority to move the barrel at this stage, although that may change later. So the main point is here we want to know what we're going to do when we are asked to move the barrel. Well, actually, I think we do need a parameter for a start, because I think we need to take a aim direction in. So we're going to move the barrel towards, and that actually may be a better name, f vector aim direction. So move barrel towards, I'm going to rename to, just because I think that's going to be a better name. Waiting for IntelliSense to finish its work. Okay, so here we go, move barrel towards like so. Great. So we're going to move the barrel towards a particular aim direction. Let's just pass that in here. And it missed, the IntelliSense for all its joy, missed this instance here. So let's just check it also got the header file. No, it's been completely useless. So we shall do it manually. Move barrel towards f vector aim direction. All right, so we have a method that's going to move the barrel towards an aim direction. What is that going to need to do? Well, it's going to need to work out difference between current barrel rotation and aim direction, and then it's going to need to move the barrel the right amount this frame given a max elevation speed and the frame time, because we want to be frame rate independent. All right, so that ultimately is what we're going to do. We're just going to work out where the barrel's pointing compared to where we're asking to point it, and then decide how much we're going to move the barrel this frame. Now, we'll just do elevation for the moment because we don't have a reference to the turret yet, so we're just going to deal with the barrel for this one. While we're here, let's get rid of begin play and tick just to lean this code down a little bit. Do so the same in the header file. The aiming component doesn't need begin play or tick, so that will make life simpler. As I say, the less we can have on the screen, the easier this is to reason about. While we're here, let's talk about a to-do, which is add set turret reference, because we know we're going to need to do that later. As I say, for now, we're just going to move the barrel towards a particular place. Okay, I'm just going to compile because we've got a bit of a compilation error there, or a bit of a IntelliSense complaint here. Well, we did, but actually it's gone already. But I'm going to compile anyway just for safety, just to make sure that what we've got as a template is good to go before I start writing code in it. And I'm pretty sure that this will compile just fine. There it goes. Okay, so now we're actually ready to do the coding. So how do we work out the difference between the current barrel rotation and the aim direction? So let's start by getting the barrel rotation. Now, if any of you know about quaternions, hold your horses. We'll talk about that in a future video. Let's show you the problem with not using quaternions first. So we're going to get the barrel's rotation like this. We're going to get the get forward vector on the barrel, which is just a, well, let's take a look at the barrel really quickly and show you precisely what that is. It is just the x direction vector. It is the direction that the barrel faces in. That's the forward vector we're getting, straight down the barrel. And then from that, we can turn that into a rotation. So we can go dot rotation. Oops. Now, what is a rotation? It is just a roll, pitch, and yaw in a single struct. Let's just take a look at that, an F rotator. With these types of things, if you've never seen the type before, type it into Google, take a quick look. It'll tell you what it is in the documentation. Here it is. It's a struct which contains roll, pitch, and yaw. Okay, so this tells us the roll, pitch, and yaw of the barrel at the moment, which is going to be pretty static. There's no point in us logging that out. Now let's look at the aim as a rotator. While we're here, let's be consistent. Barrel rotator, aim as rotator. Okay, so aim as rotator is going to be the aim direction. And you guessed it, we need to convert it into a rotation, so dot rotation. Now, we're welcome to have a quick look at that, the aim as rotator. Why don't we do that? Why don't we just make sure that it's getting through, that every frame, once we've got a solution, we send an aim direction and we see what this rotator looks like. So UE log out this thing. Now, warning text, and then I'm going to come and say barrel or aim as rotator. And what is this thing? It's a rotator. It's probably able to be converted to a string. So we're going to go star, anticipating we're going to need that. Aim as rotator dot toString method. Getting everything in the right place. Let's try this and have a look and see what the aim as a rotator actually comes out as. Of course, I need to compile for that to work. All right, so if we play, here you go. You've got a roll, a pitch, and a yaw. Now, if it can't find an aim solution, it stops printing. But if it can find an aim solution, then you can see here that it wants me to pitch, to hit that tank, for instance, it wants me to pitch 8 degrees off the horizon, yaw 5 degrees away from straight forward, and not roll at all. It never wants us to roll. Now, for this guy, it wants to pitch up quite high, or depends how far I want to go. If I go just over his head, you see it's pitching 65 degrees, but if I'm going to the tank, it's 7 degrees. These look like feasible values, so that's good news. We've got a roll, pitch, and yaw of the barrel that we're looking to get. So, what next? Well, we said that we needed to work out the difference. I think that we just have to do one more line for that. It's an auto delta rotator, which is the difference in rotation, which is aim as rotator minus barrel rotation, or barrel rotator. There you go. And we could log that delta rotator as well if we wanted to, and that would just tell us the difference. But that's a bit boring. I'm not going to go ahead and waste your time doing that. So we've done that. We've worked out the difference between the current barrel rotation and the aim direction. That's cool. So now what we need to do is to move the barrel the right amount this frame, given a max elevation speed and the frame time. Okay, well, we don't have a max elevation speed right now. So I think what we need to do is to think about having a barrel class so that we can put that information on the barrel. We have an FBX, which is a static mesh, but I think we should make a static mesh-based C++ class that allows us to specify the parameters of the barrel so that we can then put things like maximum elevation speed, and possibly other things like the clamping of the elevation. If you think about it, this tank's barrel can't move up and down as much as it likes. There's a limit to how far down it can go before it hits the tank, especially when it's facing backwards, and there's a limit to how far up it can go without it looking stupid. So we need a few parameters inside the barrel, and I'd rather put those at the barrel rather than levering them into this class here right now. So we actually can't do this little bit yet because we need a max elevation speed that we don't have. So what I'll do in the next video is go ahead and create a barrel C++ class with you, and we'll use that to put in barrel related properties to keep all things in the right place. So see you there.